All right, it's amazing to see so many people still here. It's been a crazy week, and I see you still coming and listening. It's very good. Thank you for coming. Imagine your entire school experience is managed by principal alone, from kindergarten till graduation, from teaching math to serving lunch. And then, to feel the difference, think about that every teacher, every cafeteria worker, and even a janitor has a say to make school life better and bringing their unique experience to their domain. We will be talking today about decentralization and when it makes sense. My name is Maria Zakurdaev. I'm from Israel. I'm a Microsoft Data Platform MVP and a Data TLV organizer. Data TLV is the Israel Data People Gathering, annual Data People Gathering. And if you want to visit our pretty country, well, maybe next year when things get a little bit safer, but you're welcome. Check us out, datatlv.com. Come over as a speaker or as a delegate. We don't have a lot of time today. It's just 20-minute session, but we will try to go through why would you consider shifting into decentralized data architecture? What are the pros and cons for both, for centralized and decentralized architectures? How to start moving? What are decentralization enablers? And then how not to mess it up. I like this analogy to think about monolithic data platform as a public school. It's heavily regulated. It's open for every child, right? But it's consistent, uniform experience, and it serves everyone regardless the unique child needs. Now consider homeschooling. As an alternative education style, what's the difference? It allows parents to take full responsibility for the education of their kids. And the discipline issues are avoided, no dependency on other kids, and then you can adjust the teaching method to the kid's special needs. Just as public school emphasize standardized schedules and viable minimum in terms of tests and classes, then homeschooling prioritized personal flexible schedules and personal interests. So first thing that is when we discuss decentralized architecture is the domains. And the domains is essentially a context that helps us to ensure that data solution is perfectly aligned with the goals and the needs and unique requirements of the consumption teams. Over the last decades, domain-driven design was applied to the transactional systems and operational systems. You think microservices, polyglot persistence, every transactional application can choose which product to use, which database to use that serves its specific needs. And then in data platform, in analytical data plane, the domain consent is heavily disregarded. We only think how we just push all data into centralized location with the pipelines. And so we start building monoliths, start building procedures that allow us to fit everything into the same model, and use the same technologies. And thinking about decentralizing analytical data plane is reversing your thinking, reversing from pull and ingest model into serve. And this concept was first defined like 5 years ago by Zramak Dehani. And the idea is instead of maintaining central data place, central data platform with the same uniform technologies, domains would just keep the data that they generate to them under their responsibility and host it and serve the analytical data sets in easy consumable way. And what is the mesh? Mesh is really versatile, very strong material. It is elastic. It's distributing load. This is why it's strong. It's distributing load and resisting stress. And strength of mesh structure depends on several factors. Material from what it is made, size, shape, and how strengths intersect. And if mesh is not correctly connected, if something happens to the strands, then it will deform and break. And this is a very important thing. How do we build those strands in the data mesh, in the decentralized data platform? So if we think about data mesh, it's an inverted model. It's not anyhow connected to technology stack. It is a mindset where you, instead of central decision making, you give the teams, the domain teams, to decide which technologies they want to use, how do they want to serve data, and how will it work. So some people claim that it's a buzz that is being driven by data virtualization product companies like Denodo, Dreamio, Starburst. But think for a little. If analytical dataset is owned by domain, you don't need to move data around. Okay, there is no duplication. It lowers the time that the data is ready for analysis. It lowers cost. And independent datasets, independent nodes on the mesh are very easy to upgrade, scale, or move from one technology to another technology. And then a data mesh would be built from the 3 different pillars: shared data platform, which avoids duplicated efforts, because we don't want each team to invent the wheel, to reinvent the wheel. It will help to build data products. We'll talk about data products in a minute. Build our analytical data sets. It is domain agnostic. It will serve everyone. And then we will have our data sets. And what does it mean, analytical product? We will have our microservices and transactional database. And as we know, they can be sitting everywhere, polyglot persistence, right? And then every team would decide, do they need data lake? Do they need something else? And there will be different data lakes in each domain. Or maybe they can use one technology. Okay, again, it doesn't really connect it to any technology. It can be the same SQL server, all right? It doesn't make sense because it doesn't scale well, but it can, all right? It doesn't matter. It only if technology would be chosen by the needs. But each team can decide. There is no central unit that will enforce this decision on the technologies. So every team would have its analytical data sets, data products that fit their consumers, internal domain consumers. But as we said, in order to mesh, to be elastic, we'll need to think how strengths are well set. And this is why we will have federated governance that will help to nodes to be able, that will help us to to analyze the data products together, to find data products. It will define standards for syntax, metadata. It will help to correlate and intersect data products if there is a consumption need to intersect them. Again, this is something that needs to be considered. If there is too many needs to intersect between data products, that maybe they belong to the same domain, then maybe they need to sit together. So computational governance will define the rules, but it's not like traditional governance, because traditional governance attempts to apply centralized decision-making and global canonical representation of data. And data mesh federated computational governance, it embraces changes, embraces decentralization. And it just helps for consumers to consume data products. Now there is no the best architecture, right? There are pros and cons in both. So there are challenges in both, and if you're talking about centralized monolith, it implies centralized responsibility. And if there are, like in my team, we have different products, and if many people work on everything, then there is no clear owner. Like if there is an issue in one product, they start pointing fingers. No, he touched it last time, and when you have a team that generates the data, takes care of it from end to end, it's completely different in terms of data quality, in terms of usability of the data set. It's hard to scale one big system, and it's hard to model data for every use case, and again, hard to maintain data quality. The challenges of decentralized architecture is there is a risk of creating data silos. I skipped one slide, and it's actually, I like to stop here. Like the enterprise data warehouse engineers, they're really siloed by their knowledge. They consume data with little understanding. They consume data from source team, and then they provide data to the domain experts, and they're like in the middle, and it's really, really hard to have context of everything, of different domains. And then, decentralized architecture, of course, it's not easy to maintain each of them. It's hard, right, to build perfect architecture. And there is a risk of creating data silos if we don't take governance into focus, if we don't think about how we make those our data sets, our products consumable, there is a risk of creating data silo. Operational teams don't really like to take ownership of data quality, and it's hard to maintain reference data in isolation. That might need to be sit in some central location anyway. How do we enable decentralization? What helps us to get there? First thing is decomposing domains. As I said, it can be challenging and really flexible, because some domains would work together, and actually each domain would represent fact and reality of the business. Some domains will align to the consumption, some domains will be aligned to the source, but not every data set that is generated in the source is the domain. There will be probably grouping. Here in this example, I have borrowers and library and loans as a different domains, or they can belong to one domain if they are analyzed together. Product thinking. This is another foundational term to data mesh, because we need to apply our product thinking to the analytical data sets that we build. And like if in this example, if we build skates, we will think, why do we need new skates? And what our competitors have? Who is going to build them? How we call them? How much do we charge for them? How do they help the consumers? When we're going to build them? All those questions can be asked in regards to our data sets. And this, when we think about our analytical data set, about our data product, it helps it to be consumable and shared and governed. In order to do that, we must have intimate knowledge about data product consumers. Who are they? How do they use the data, and what are the native methods that they prefer to work, to consume the data that we're building. And bringing operational data and analytical data closer together, it makes sense, because this is an ecosystem, and it can easily be scaled out. And if you have a new data source or new use case, you just add another node to the mesh. Another architectural enabler is data fabric and data catalog. And this is the virtualization that would bring all the dispersed data sets together, because it will have the central data consumption layer. It allows the users to connect to data sources that can be scattered everywhere in files, different data lakes, data warehouses. It will allow effective data management of disparate data, and it will have data catalog as a part of it. And the modern data catalog is very important data fabric unit. It allows, it is not like manual data catalog, old style. It is driven by metadata, it's automatically updated, and it makes product discoverable, secure, and accessible. It enables governors through allowing different people to access different products, and it has embedded collaboration where you can give the, you can show the data quality of the product, when it was last updated, and a lot of information around it to make it discoverable for users. And very important, data mesh enable is shared data platform. It is domain agnostic, as I said at the beginning. It should be serving everyone, every domain, most of the domains. Maybe some will have separate data platform if it makes sense. It will take care of data product versioning and building data products and their life cycle. They will publish the data product to the catalog and will take care of data quality with collection and measuring metrics. And this is an example, this is the same slide as you had in your session. And this is an example of the data mesh on Azure, where we clearly see different teams, and each one of them has its own technology that makes sense to use to build the data that serves the best the consumers. And we will have data governance in the middle and shared self platform in the center that will join the nodes on the mesh together. How not to mesh it up? How much I have? 3 minutes. Okay, I think we're fine. Why you shouldn't implement the data mesh? First, if you're a small company, like 50, 100 people with 1 DBA, 1 data engineer, there is nothing to decentralize. That you probably will have just 1 domain, and it's okay. Then when company grows, then it starts to make sense to decentralize things. If your organizational culture does not empower bottom-up thinking, then it won't work. Because there shouldn't be no central body, central unit to maintain sufficient context on all the technologies that will be used on the nodes and influence decisions in every domain. There's a lot of information out there. There is this Slack community. There's a lot of people exchanging ideas, their vision of data mesh, how they implement it, when it makes sense. Really interesting. There is Data Mesh Radio, a lot of podcasts, again, lots of information. But really foundational to understand that we just need to reverse how we think about the data. In order to decentralize a monolithical platform, we need to shift from push and ingest vision to serve and pull model. And data lake is just a tool. It's not central concern. All right, you could use it. You just don't have to. And it should be shared. And it can, if it makes sense. But it can be different data lakes in the organization. And then we would bring data for analysis through fabric tools, through data fabric tools, through the virtualization layer. Large organization that looking for scale will eventually adopt some kind of version of data mesh. And thank you. And you don't have to be here or there. You don't have to be centralized or decentralized totally. Being somewhere in the middle also makes sense. And it can be challenging, even unrealistic to implement in many organizations. Some can say that it's data chaos, but with the right approach, it can even be perfect. Thank you for listening. And there is one more thing. There is a feedback loop. There is also a very important thing inside data mesh that it helps. It has a very important role. It helps when data consumers provide feedback to the nodes, it helps the quality, usability, and relevance of data products. So as we are sort of nodes on this mesh, and SQL Bits connects us together, if you can provide me feedback, then we'll be happy, and it will show me my material, is it usable, and if it's relevant to you. Thank you. Do we have any questions? No? Okay. Thanks. If you have any questions, I'm here.